My name is Karen King, and it is my great pleasure to introduce my friend and fellow KK in the math education world, Karen Karp. She is a visiting professor at Johns Hopkins University's School of Education. For 21 years, she was a mathematics teacher educator at the University of Louisville in Kentucky, where she is now Professor Emerita. She is a former member of the National Council of Teachers of Mathematics Board of Directors and a former president of the Association of Mathematics Teacher Educators. In addition to Karen's background as a certified mathematics teacher, she is also a certified special education teacher. She continues to work in classrooms to support teachers of students with disabilities in their mathematics instruction. Karen is the author of more than 25 books, including Elementary and Middle School Mathematics, Teaching Developmentally with John Vanderwall and Jenny Bay Williams, Developing Essential Understandings of Addition and Subtraction for Teaching Mathematics in Pre-K through Grade 2, and numerous book chapters and articles. Her 3 articles, co-authored with Sarah Bush and Barbara Doherty on rules that expire, have appeared in each of the NCTM journals for teachers. So without further ado, I'll let Karen talk to you about mathematics education and special ed.
Thank you, Karen. After the former 2 presentations, I'm a little worried. I will be bringing a different touch to the day's events. So I'm going to start with just a little overview of what is happening in math interventions and maybe what isn't. What we're thinking about today, as I briefly discuss these issues with you, are what are some of the important components of effective math interventions. And I'm going to be frank, we don't know a lot in math ed. The kind of research that you're seeing in reading education is so much more advanced and so much more in-depth and so much more long-term than what's been going on in math ed. We are coming late to the conversation, and so that will be a part of what you see today. Would the teaching of tricks, shortcuts, quick rules be the appropriate thing to do in math interventions? And how can we use math intervention time, this precious time that kids get extra math, to make math memorable and relevant to them? So what are some of the differences if a student really had a good understanding of a mathematical concept and other students who may have just in fact memorized it in the way we might memorize a phone number and tomorrow not have any idea about it? Or for kids with disabilities and who struggle with memorization, it may not be their strong suit. So we have a diagram that's based on the work of Skemp and his studies on a continuum of understanding in mathematics. And what you're going to see here are instrumental understanding to relational understanding. And I'll start with relational. That's what's going to happen with you while you're at this wonderful conference. You are going to learn new things, and as you do, we're representing them in these diagrams with red dots. You immediately link them to, and I see people taking very strategic notes, linking them to other things they're going to do, maybe something in your work, your research, what you might do with your own child for the parents who are here. You web all of that information to prior knowledge. You're connecting it to things you know, to people you know, to children you know. When we do things in math and pass out new information through our instruction, many times children do not make those connections. They do not web them out. You may have not known this yourself, but there are many children who, when we teach them the multiplication facts and multiplication concepts, when we get to division, it's a whole new world for them. And you know, you might be doing 20 divided by 5, and they'll say, I don't know, I've never seen that before. And you're like, we just did 4 times 5 equals 20, you know, and it's not making the link. That would be what we would call an instrumental understanding. And it's my position and the position of many that the creation of blue lines is the work of mathematics educators involved with interventions. We must create blue lines for kids who are struggling to do that on their own. And that gets back to the very conversation we've been having since the first presentation on explicit instruction. So we have intervention recommendations from research that I'm going to weave in and out of this conversation we're having. The first is concrete, semi-concrete, abstract. And sometimes in special ed, they call it CRA. I'll probably offend a whole bunch of you. We don't really in math ed like the R. Why? Well, CRA is concrete, representational, abstract. But in math ed, we believe these are all representations. Concrete is a representation, abstract is one as well. So we call the middle one semi-concrete. So sorry if I offended any. We are going to talk about explicit instruction. And I'm also going to talk about explicit instruction with teachers, because I'm really a teacher educator. That's the work I do. And we're also going to focus on underlying mathematical structures and the importance of making sure kids are getting a sound foundation of those. So this is just a model of CSA. And the main reason I wanted to just present this just briefly is I don't want anyone to really believe that concrete must come before we start doing illustrations, sketches, or pictures, and that must all come before abstract. That is just not true. It's interwoven. And we weave these together so the kids can see the relationships between these varied representations. And this is how it might look. And most of what I'll talk about today is at elementary. That's what I focus on, and that's where I believe we need to make sure we start with a strong foundation. And so this is just a word problem. And again, it's just another way of looking at it from a concrete model to sketches. And notice that we are going to be talking about very strategic and explicit teaching of how to make sketches in math. If we have 3 monkeys and 4 trees, the last thing I want kids doing are drawing trees and monkeys, okay, just as a heads up. So what we want to do is make this explicit and make sure we're focusing on the mathematical ideas. So what do you think takes place during interventions in mathematics? Again, I've told you that there's not a tremendous amount of research out there, although there's many people in this room that are working very hard on changing that. But just talk to a person right next to you and say, well, how do you think teachers are getting the strategies that they're using for interventions? What do you think their process is? You're only going to have like 30 seconds, so go. All right, let's come back together. If you were talking that they're reading the research on all of this, there's not a lot out there. If you were saying that they're going to math conferences, there's not a lot of presentations out there about students with disabilities. If you're saying that they're going to special ed conferences, not a lot of sessions there about how to teach math. It mainly focuses on reading. So what do they rely on besides Pinterest? I didn't say that. What they may rely on is how they were taught. How they were taught themselves. The 13 plus years of math education that they had. So if that's the case, let's just take that as an angle, because it probably is the case. What did you learn in elementary school? So you're going to have 2 minutes to talk with the people around you. Okay, here's the deal. We have rules on the right side here. Were you taught these rules when you were in school? If you were, are they good rules to teach? And if not, why not? You have 2 minutes. Go ahead and chat. Look at the rules on the right. right, we're going to come back together. All right, so just as a reminder, the rules we're going to be chatting about one at a time. Addition makes numbers bigger. Okay, maybe some of you heard that when you were in school. Multiplication makes numbers bigger. Or how about when you multiply a number by 10, just put a 0 on the end of that number. Or the longer the number, the larger the number. So we'll start with this. This looks like a fine rule to me. All right, you have two add-ins, you add them, you're going to get a larger number. Is that a good rule of thumb? When is there an issue with this rule? Yes, exactly. When we start to look at negative numbers, and again, and I'm going to be funny here, and I'm not meaning to demean teachers because this is the group I work with every day. The teacher might say to themselves, that's a long way down the road. I have these standards I have to get through this year, and these are the things that I must teach. They don't quite say it, but could it be someone else's problem? It could be, except that rule was bad the first day you taught it, all right? The rule was never good. It was not a good rule to teach, and so therefore, we have to really focus on this kind of work. What about multiplication? Well, this looks like a fine rule also. Is it? When does it go wrong? Fractions. And, yeah, and it also was wrong the first day you taught it. So what we are doing with these, are we're calling these rules that expire. Rules that work for, some cases not very long, to rules that will eventually explode as kids move through the system. And we can see that these have tremendous effect on children with disabilities as well as all children. Now, this is a dandy rule, and the reason I know this rule is, oh yeah, I taught it. So what about this rule? Is it a good one? You're not really learning the concept, that is for certain. But what else about the rule? Is it going to go bad? Is it going to have an issue? Decimals, sure. And so it's funny that I have the things that you say, isn't it? But the decimals. But the reality is a child who was in my class could have put down this answer, all right, when given that problem. And when the teacher says wrong, they say like, wait a minute, like old lady Karp just taught me that like a year and a half ago. And what's the deal? Well, you know, it's wrong. And so you can begin to start to see that this pattern, and we'll just repeat one more. Did you think I gave you one that was going to work? Well, of course not. So that doesn't work either with decimals. But we're seeing a pattern here of rules that explode, expire, rules that go wrong. And when we, Barb Daugherty, Sarah Bush, and I started to write these articles, when we looked at the exact expiration date for all of these rules, it's upper elementary and middle school. Might not be a surprise to you, and it makes us very curious as to, isn't that the time when kids start disliking math? Isn't that the time when kids start thinking that math is quite mysterious, unknowable, and maybe even magical? Well, it is. So students use these rules not as we intended, and maybe not with the boundaries and parameters that we know, but as they have interpreted them, and as they really make them their own. And to be honest with you, they hold on to them, and I'm going to show this to you. They hold on to them long after they should. They don't think about the rule in the long term because they don't know what's coming up. They don't know what's ahead. But what we do know is even the strongest math students are unnerved by this whole situation, that teachers have taught them something that may not work or be true. So as Karen King talked, we wrote 3 articles. The first was for math teaching children math for elementary school teachers, and we gave them the 13 rules that expire, but when we did this, we also gave them words that have already expired. Well, and when we do PD, we work together on this. We're trying to work with teachers to get them to stop saying things from the past of their own own elementary school experience. And so we don't want them saying things like reducing fractions, when in fact fractions are not getting smaller, they sure are not going on a diet, and none of those things are happening. And so the language that we use is really important, and the consistency of the language across an entire school does make a difference. So we were so intrigued by the response to the original article. We wrote one for middle grades. Don't think that middle grades teachers were exempt from this. And then we also included notation that expired as well. Notations that teachers use that are not effective and don't connect to high school. And this article is coming out this next month for the math teacher, for high school teachers, because if you think they're exempt, they're not. So this is the work of Barb Doherty and Ann Fagan, who've been working on progress monitoring tools that really get a kid's conceptual understanding. And this is one of the problems that they had on there, and I'll just read it to you, and you can read the responses. But Mari said 2t is always greater than t plus 2. Do you agree with her? This is one of their items. So you can read the answers to yourself and think about what children might select. And what they found, Barb and Ann, was that almost 42% second semester Algebra 1 students selected A as their answer, completely linking back to the rule that expired that we talked about that happens at the elementary grades. So what do we know? We do know that telling isn't teaching. And to spend time in interventions telling kids over and over again something is not enough. Surely, giving them a worksheet with a stopwatch is not either. And so what we're saying is that telling isn't teaching and told isn't taught. How do we know this? Well, we know this even with gen ed students. If you want to teach them multiplication by 0, I could do like what was done to me when I was in elementary school and say, all right, kids, this is an easy one. You're going to love this one. 0 times any number is 0. Okay, that means nothing. But if I get a kid on a number line to stand here, and I'm going to separate myself in the microphone for a second, and first show them by a blue line what would 2 steps of 2 be. And they actually do that on the number line for me. I'm going to connect that with blue line with what I'm going to ask them now. Take 5 hops of 0. Think about it. That's what makes a difference. Take 0 hops of 8. That's the kind of work that we need to be doing in interventions. It's not about telling. And interventions, this time frame, provides opportunities to spend time with kids who are in a classroom where kids are answering rapidly and they don't get a chance to think about it. They need to act it out. They need to do the math. So this is also from my colleague Barb Doherty, who you'll hear at this conference as well. She talks about the creation of mental residue. So what's there after the kid has had a learning session? If it's just memorized, sometimes that is erased very rapidly. But if they've done it, they've stood on the number line, they've actually jumped the units, they remember, and they get what Barb describes as mental residue. So there's one other thing in these rules that expire that I cannot leave the room because I'm on a personal and national campaign on this in case you haven't heard about this. Keywords, the use of a keyword strategy. And what I mean by that, for those of you who might not know the strategy, that's a miracle, but I'm grateful. It means that there's some sort of chart, possibly, that says if you read this word in a word problem, then you do this. If you read In all, add. If you read this, subtract, and so forth. So what this yields is a problem like this. The children just skim it. Skim, 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 skim. In all, I see it. Add. Take those numbers and add them. All right? Well, Art Hyde, in this book called Adapting Reading Strategies to Teach Math, said, what kind of message does that give? He said, it gives them a message, don't read the problem, don't imagine that situation, don't try to imagine it in your head, don't completely ignore the context, abandon your prior knowledge, and just grab those numbers and compute. So, why do we want to avoid a keyword strategy? Well, there's a bundle of reasons, and here comes some. There's no real sense-making and meaning-making, which is really what we want to teach kids. That's really the deal in math, is meaning-making and sense-making. It does not build any structures for more advanced learning. Some of the schema that people are working in this room, such as Asha Jitendra, those kinds of schemas last, and the kids can keep them in their head over time. Assessors know keywords don't appear in a lot of problems, and in a life they don't appear in a lot of problems. Kids consistently use them inappropriately. But if there's one reason, if you reject all others, two-step problems start in second grade, and there's no way to use keywords with a two-step problem, because you don't know what part goes with what. Now, there are posters that are used in classrooms, like the keyword one. And this is, I think, important to our conversation I'm going to be getting to in a few minutes. Some of these are problem-solving strategies, and those are fine. But the reality is, and this is what I'm talking about when we're thinking of students with dyslexia and students with disabilities, at the local elementary school, you see a different poster almost every grade. It depends on what the teacher picked up. Notice that E means different things, S means different things on these various grade levels. This kind of inconsistency, this kind of lack of precision across an entire school is something that we are working full-time to change. Because kids with disabilities need consistency. They need familiarity. They need to say, oh yeah, I saw that last year. Oh yeah, I know what that is. Oh yeah. Because if we believe they need more practice with something and they need more exposure to something, changing it up every year is not helpful. So again, with sense-making and word problems, we're finding that kids use what the strategy they use for the word problem is, what have we been doing this week? All right? We've been dividing, I'm going to divide. If we're subtracting, I'm going to subtract, and so forth. But we need to spend time in intervention sessions building the underlying structures. So let me share this problem with you. There are 25 sheep in a flock, and 25 sheep and 5 dogs in a flock. How old is the shepherd? Now, my happiness comes from your laughter because you're making sense of this. But what do you think about children? We did research with about more than 200 kids in the Baltimore area. And we asked the third graders first. So the third graders said, oh, yeah, it's obvious. 76% of them said, shepherd, he's 30. It's very clear. All right? 8% said he's 20. And one child said, you can't figure it out from what they said in that problem. But look at this. This is really what I want to show you, because 6th grade, 50% of the kids are still telling us the shepherd is 30. And because now they can multiply, oh yeah, we've got 21% saying he's 125 years old. All right? And we have a little bit more saying, you can't do that problem. 7th grade, a nanosecond possibly away from algebra. 50%, 48% are still adding. We have 17, but because we've been doing ratios that week, 14% of them are trying to make a ratio out of this information. So what I really want you to focus on is this. If you don't do anything, if there is no explicit instruction about problem solving, it is not going to happen just with maturation. It is not. I mean, it's going to happen slightly, but not enough to make any difference. And I'll just tell you that one, yeah, I know. I just had to share it. I told you this presentation was going to be different. Oh, because shepherds are really old. So, can interventions provide different options? Sure they can, because we could share a problem like that with a small group of kids, and we could say, oh, in Ms. King's class next door, kids already solved this, and here are some of the answers they had. Are these all right? Are some of them right? Are none of them right? And let them think about it, talk about it, and really make sense of the problem. And they can do it without other kids jumping in with an answer. They can really get a chance to think. And this is where we get to multiple representations and the importance of them in having kids make connections, where we have a real-world situation or a context and a word problem, and we show how that relates to the symbols, diagrams, sketches, manipulatives, and so forth. And that's when we can really tell how kids can understand a concept. Can they make all of these links, all of these blue lines? So, again, this is just a recap. Avoid giving kids math tricks and rules without full connections to concepts and understanding. Again, a perfectly notorious one is division of fractions. How many people can do it, and how many people have never used it in your life because you don't even know when it comes up? Engage students in doing math in these interventions, and make it at a pace where they are allowed to discuss and think about concepts with each other. And when we think about developing effective interventions, are we working as a group or as a team? So we're asking teachers in schools, are you working as a group or as a team? How about teacher ed in school districts? Group, team. How about researchers? Group, team. What would it take to shift the work from that of a group, just a collection of individuals, to an actual team? And how could that change, hopefully, the outcomes for children, which is all that we really care about? So we've developed something called the Whole School Agreement, and by we, I mean myself, Barb Doherty, Sarah Bush, and I'm going to include Amy Lingo, who's helping me carry this out in schools all over. And what we've been doing is we have teachers and schools decide on the language and models that everyone in the entire school will be using. Everyone. No one is saying borrowing across the whole school. No one's saying carrying, no. We engage paraprofessionals. We engage student teachers in this. They must come to the PD that we do. We engage long-term subs, parents that volunteer frequently, grandparents that volunteer frequently, because a lot of them are undoing the work the teacher is doing, all through good intentions. We prepare all students, not just for my grade, not just for the test at the end of the year, but to leave the school with everything they need to be successful. And particularly, we're having elementary teachers moving kids to middle schools. We want to engage them in doing mathematics and building long-lasting understanding in this process. So we get rid of things, and we decide what we're all going to be using in the entire school. So the kids hear the same words over and over again every year. We're deciding what models that we're going to use, starting with younger children, moving up along the way. We're deciding with what notation. How are we going to build this? From basic unknowns with an empty box or a question mark, and what grades are we going to use those things, to a letter as an unknown, but we can't forget that letter has to turn to a variable. Who's doing that in-between work? I'm responsible in 6th grade for teaching as a variable, but did anyone help me before then to help kids see the segue between a letter as an unknown and a letter as a variable? So we asked all teachers to do this, and again, I've explained this already. But here are some of the things they agreed to. And again, we have boatloads of these, but we're just highlighting some. Regardless of the grade level, everybody's talking about the mathematical properties as they should be discussed. They are not using weird things like the flip-flop property or ring around the rosy property because they think it's cute, and then to have the child get to third grade to multiplication and go, I think that's the ring around the rosy property, and the teacher goes, what are you talking about? That gets kids, all kids, but particularly students with disabilities, in a situation that they don't need to be in. We talk about models, particularly number lines. How are we going to start with kindergartners highlighting the unit, not the tick mark, the unit? And how are we going to build that till kids are using empty number lines as they get into upper grades? Schema models, which I talked about, to solve word problems in particular, and relational approaches to symbols such as an equal sign. And so how is that going to be built from kindergarten to 5th grade in your school? So what we should emphasize, as I said, is this action and doing math. By carrying out the actions physically and particularly, kids can actually get the mental residue that we're hoping for. And so we want to use these intervention sessions as opportunities to make math memorable. So the kids remember when they jumped on the number line, or they remember when this happened. So this is from Matt Larsen, who's the current president of NCTM. And I think it's important for us to think about this. We expect that the very best doctors will treat the most grievously ill patients. It should be no different in math education. Great teachers have the skills to help the students who struggle the most. And it is our responsibility in teacher ed, which is what I'm representing here today, math teacher ed, to make that happen. We must make that happen. And it's hard, and here's why. Because in special ed programs across this country, very few of them require a math methods class of all of their students. Now, they surely require the reading, and in many states it's a mandatory reading methods class for every teacher, because they've all agreed that everyone should is teaching reading, which is terrific. But we don't have that in math. And so we have special ed teachers graduating where they get one night of math in a methods class. We have gen ed teachers who take math methods. Some secondary people don't, believe it or not. Don't get too terrorized. But the reality is they don't get often a section on how to teach students with disabilities math. So this is where we really need to spend our time. This is where we're going, and and there's many other people in this room that have components to this as we go forward. But thank you. Oh, I was just going to say, seeing that there's no question.
So I just want to thank you for a very excellent presentation. And at the risk of sounding glib, one of my big takeaways here is that learning may involve a lot of unlearning.
Yes.
And because, I'm one of these folks who was taught with the rules and the tricks and somehow learned math in spite of those things. So, I'm wondering if you have any thoughts about the ideas in which we're taught using methods that we're now trying to move away from, but somehow are learning in spite of them. Can we know something about it? And the reason this provokes a thought with me is that sometimes in my own research on students with learning disabilities, I wonder if the difference is an ability to kind of unlearn things along the way that you may or may not have a capacity for along your way to learning a concept.
And again, I'm not going to say I have specific research to you, but I will tell you from my experience that there are many of us who kind of overcame some of the rules and have learned this on our own. But why do we have to do that?
Yeah.
You know, and that's the point you're making. And how much more would all of us know about math if we didn't have to do that? And if we had this concerted effort to make this all happen, where we did, and again, sometimes we know that students with disabilities hold tight to rules. They really want something that will work for them, and they hold tight, and it's hard for them to shake them. You know, whereas many of us, you know, have been convinced that there is a better way of doing it. And I'm going to be straight with parents in this room. A lot of parents fight teachers, and they'll say, that's not the way I learned it. You're asking my kids to do something, and why can't we just show them this way? And many of you have already heard this, but I say to them, do you go to your pediatrician and say, don't use any techniques or medical or medicine since when I was a child? You know, do you say that? You know, no. Well, I want the most up-to-date. I say, well, that's what teachers are doing with your children. They're giving them the most up-to-date approaches and the most up-to-date research-based instruction that they can. So but that's another reason why it's tough for teachers, because they're getting a lot of pullback from parents who believe the old way is a perfectly fine way to go ahead. So, yes, Barry.
Would it be fair to say that those aren't rules, as in they're not rules with a mathematical base?
That would be very fair to say, yes.
So that's the at least part of the dilemma, is that those rules don't hang together mathematically as you change through the number system.
That's correct. And yet they're presented like a rule, and they're presented in this telling approach, which becomes like, you know, you have to trust your teacher. And for the poor children who I taught, you know, and again, we all, Barb and Sarah and I all chuckled about this when we were putting it together, because we're all thinking of things that we did ourselves and had unlearned along the way, as we've said. Yep, I'm ready. All right, well, thank you so much for your kindness.